Avinash Kaushik spent the first 10 years of his career building the intelligence platforms and data warehouses that powered multinational corporations. These weren't small databases. In the late 90s, Kaushik was constructing multi-terabyte systems, physical networks of servers that represented the height of corporate technology at the time. His goal was to process raw historical information into clean reports, giving these companies a way to track and outmaneuver their competition in physical markets. For Kaushik, mastering these highly structured databases was more than IT maintenance. It was the mechanism that drove corporate dominance in a pre-digital economy. This diagram represents legacy data systems, the single source of truth. Clean, straight pathways funnel uniform data into one reliable hub. But when the internet era arrived, this blueprint was bombarded by thousands of erratic inputs, disrupting that orderly flow. At first, the system seemed to hold. It captured clickstream data from digital activities for a few months, operating exactly as designed. Then it collapsed. What was a stable business intelligence platform became what Kaushik described as a big disaster. It leads to a central question. Why did a multi-terabyte system, designed by an expert in the field, shatter the moment it encountered the internet? To understand the crash, we have to look at the baseline. Traditional business intelligence was built to handle internal, highly controlled data environments. These systems were fed by enterprise resource planning software, or ERP. They handled simple, predictable numbers, things like monthly sales totals or regional inventory counts. Relational databases forced this information into rigid columns and rows. Every piece of information has a specific, predefined home. Because the data was uniform, executives could query the system and instantly pull up exact historical facts without ambiguity. These systems worked because the corporate world they measured was finite, slow-moving, and strictly categorized. But the online world Kaushik encountered follows a different set of rules. It is external, volatile, and high volume. When users visit a site, they generate a clickstream. This isn't just a sales total. It's a record of every mouse movement, every hover, and every micro-action taken during a session. When you multiply those micro-actions by millions of users, you get this, an avalanche of irregularly shaped data cascading into the system at high velocity. If you try to force that jagged, unformatted information into the rigid columns of a relational database, the system breaks. The grid lines bend and snap under the sheer mechanical pressure of the volume. This structural incompatibility is what destroyed Kaushik's data warehouse after only a few months of operation. The disaster wasn't caused by a lack of storage. It was a failure of design. Rigid models were physically overwhelmed by the unpredictability of human behavior online. The failure led Kaushik to a difficult conclusion. The architectural rules that governed the BI world could not simply be ported over to the internet. Patching the old warehouse or adding more servers wasn't a solution. The core logic of the relational database was at odds with the nature of clickstream data. To accurately map the digital landscape, companies had to move away from legacy architecture entirely. This required a shift from analyzing rigid historical reports to dynamic systems capable of predictive analytics. Surviving the digital transition meant recognizing that the old ways of collecting and categorizing data were no longer sufficient. Today, we see the same interdependency across every major industry that interacts with the digital world. Whether it's healthcare, finance, or marketing, organizations are developing new architectures to manage their specific datasets. These modern systems prioritize flexibility and pattern recognition over the rigid, predefined categories of the past. The goal is no longer a single, pristine source of truth, but rather a way to navigate multiple, overlapping, and often messy data ecosystems. Modern competitive advantage doesn't come from forcing reality into a simple grid. It comes from building systems robust enough to map these fluid, interconnected points and find meaning in constantly shifting data.